performing full weightlifting movements such as the snatch, and clean. With correct technique can be highly beneficial for sports performance. However, for athletes who are not weightlifters, removing the catch and performing weightlifting pulling derivatives, where the intention is to accelerate throughout the concentric phase, may provide a training stimulus that is just as good. This is because removing the drop under the bar and the catch phase allows the emphasis to be on completing the coordinated triple extension during the second pull, as well as enabling a greater ability to overload the movement, as the removal of the catch allows loads greater than an athlete's full weightlifting movement 1RM to be used. This can ultimately lead to increases in peak force, rate of force development, velocity and power. Furthermore, weightlifting pulling derivatives have a reduced technical complexity compared with full weightlifting movements, and so pulling derivatives can be more time efficient to learn and can be taught as part of a teaching progression for full weightlifting movements. And regarding injuries, training with full weightlifting movements chronically may increase overuse injuries to wrists and shoulders. Therefore, using pull variations as an alternative may result in decreased stress on these joints. In the article published in the journal Sports Medicine, titled Weightlifting Pulling Derivatives, Rationale for Implementation and Application by Timothy Suchomel and colleagues, provide recommendations on how to best implement weightlifting pulling derivatives during the strength endurance phase, the strength phase, and the strength power phase, as well as highlight key points to consider. This presentation, brought to you by Talking Sports Science, will be a summary of the recommendations. Firstly, regarding the strength endurance phase, the primary focus of this phase is to enhance exercise technique, while also improving work capacity and increasing the muscle cross-sectional area. To achieve this, training volume is typically high. For example, blocks of 3 times 10 repetitions may be implemented. In terms of exercise selection, for weightlifting pulling derivatives, using pulls from the floor, hang or mid-thigh are all appropriate in the strength endurance phase. Regarding intensity, due to the high volume, light to moderately heavy loads, for example between 60 and 110% of 1RM, are recommended. And to help prevent the high number of repetitions interfering with exercise technique, inter-rep rest through the use of cluster sets may be used to avoid excessive fatigue and help maintain exercise technique. During the strength phase, the primary focus is overloading the triple extension with high force movements in order to help gain positional strength, as well as improve peak force production and rate of force development. To help achieve this, heavier loads should be prescribed, for example above 100% of 1RM. In terms of exercise selection, the mid-thigh pull could be implemented in a strength phase using loads greater than 120% of a 1RM power clean. Due to the greater load used compared to the strength endurance phase, a lower number of repetitions are recommended to help ensure high quality work during each rep. For example, blocks of 3 sets of 5 repetitions may be implemented. Moving on to the strength power phase, the primary focus here is to develop peak power. To help achieve this, a range of loads should be prescribed. This is because peak power has been found to be specific to the lifter plus bar system, the barbell, and in relation to specific joints. Furthermore, the optimal load to develop peak power can change with train state or accumulated fatigue, as determined by relative strength level. Therefore, using a range of loads to achieve overload will ultimately allow the development and improvement of lower body power across the full spectrum of the force velocity curve. In terms of exercise selection, the jump shrug, using loads of less than 45% of 1RM hang power clean, often feature in the strength power phase due to it being highly ballistic and its ability to maximize peak velocity and peak power. In terms of the volume for weightlifting pulling derivatives used in the strength power phase, it can be reduced from using 3 sets of 5 reps to 3 sets of 3 repetitions. It's important to point out that weightlifting pulling derivatives can be implemented throughout the training year, but an emphasis and de-emphasis should be used in order to meet the goals of the particular training phase. If adopting a phase potentiation training model, the strength endurance phase should enhance the subsequent strength phase, which should then enhance the strength power phase of training. When incorporating weightlifting pulling derivatives, there are three main key points to consider. First, athletes must exert maximal effort with the intent to accelerate the load as rapidly as possible, as without the appropriate effort and specific training mentality, the effectiveness of weightlifting pulling derivatives is likely to be diminished. Second, weightlifting pulling derivatives can be used for both technique work and developing strength power characteristics. Lastly, athletes must be coached appropriately, where they are provided with good demonstrations and various forms of feedback. This is because, as with any exercise, proper technique is crucial and provides a foundation that allows athletes to progress to heavier loads, ultimately enhancing their strength power. And that concludes this presentation. As always, I recommend you go and check out the full article by Tim and colleagues for a deeper dive into the nuances surrounding implementing weightlifting pulling derivatives. The link is in the description. Thanks for listening, folks. See you next time.